Welcome all. Good afternoon. It's been very heavy rain since morning in Delhi. I hope the weather is good there. Welcome to today's webinar hosted by Numerical Analytics Instrument Private Limited. So today we have a very unique topic, Voronoi, and we will look the scope beyond the Voronoi with Mr. Jalaj and Ms. Greta Gomes. Mr. Jalaj and Ms. Greta Gomes both are the T-Cube trainer with us. Jalaj is also IBDP examiner, curriculum leader in Indonesia, and Ms. Gita is HOD mathematics in the Stonehill International School in India. So, without a further ado, I would like to welcome Mr. Greta and Jalaj to start with the topic Voronoi and beyond.
Thanks, Hassan. Thank you so much. Greta, should I go first or would you like to go?
You can go first, Jalaj. Thank you, Hassan.
Okay. So I would like to welcome everyone once again to yet another very interesting webinar organized by Numerical Analytics. And with me is my enthusiastic colleague, Greta. She's from Bangalore. Bengaluru. And she is a trained dancer in all Latino dance forms. I don't know how many of you are aware of this. And also she's also a very melodious pianist. She plays piano, lots of pieces. I haven't heard, but I have heard a lot about her piano skills. So Greta, you are into dance and music. So I would like to ask why some musical compositions are more famous and more melodious. For example, let's say we can see some of those old Bollywood songs. They're still very melodious, and you feel like listening to them again and again. There are so many remixes of those songs. And when it comes to classical, if you see why Mallikarjun Mansoor is so famous, and maybe Pandit Jasraj Kumar Gandharv, or when it comes to Fifth Symphony of Mozart, Beethoven, and lately this gentleman Yanni. So, and also I've been seeing that for many years now that the students, they like to explore maths behind famous musical pieces in their internal assessments.
Yes.
So.
Yeah. So actually, I think the Symphony No. 5 is by Beethoven, and he was kind of blind when he composed that piece. So it is about the patterns hidden beneath the beautiful sounds. Mm-hmm. So whether it is the Moonlight Sonata, you would notice it is grouped as triplets. And I think the interesting question here is the patterns create a consonance, especially captivating when it is cleverly separated between consonance and dissonance. And the contrast of these with the certainty of math is what defines the elegance of the pattern. But it is yet to be discovered, like you rightly pointed out, why you are attracted to some Bollywood songs or maybe the symphony number by Beethoven. So it is yet to be discovered why certain sequences of these patterns strike the hearts of listeners in a certain way.
Great. Thank you so much. And so what is the plan? So are we exploring something which, like Hassan mentioned, possibly something that we had never discussed in our webinars? In fact, if I remember, I have never attended or I have never seen any workshop on some of these topics like Voronoi Diagram. And modeling techniques, yes, there are some webinars and there are some videos on modeling techniques, but when it comes to modeling in context of internal assessment in new mathematics, that is MAA and MAI, and also Voronoi diagram. So I don't think this has been covered before.
You're absolutely right. And I would like you to share with us your understanding of a Voronoi before we move on further.
Okay, so let me share my screen and my understanding, and feel free to agree with me, feel free to disagree with me at any point. Wherever you feel there's a scope of some discussion, please stop me. I'll be very happy to listen to what you feel and share what I feel. So exploring Voronoi and beyond. So this is our today's topic. So before we start formally, let's have a look at this quick video. I recorded it long back, so my apology for like quality of sound, quality of video. It is not that good. It is little about Voronoi pattern. Before getting into Voronoi diagrams, let's explore what Voronoi patterns are. So this is, I think, 55 seconds long video. So enjoy it.
Is randomly on a plane. Imagine. Hello. Consider some points placed randomly on a plane. Imagine there are tiny bubbles generated from these points. Let's call these points sites. When these bubbles are blown into larger bubbles, they expand, collide, and go into a line where they squish together. Draw a line at this bubble boundary. When the similar process is carried out for many randomly scattered points, this is what happens. We get an irregular puzzle pattern, which is called Voronoi pattern. These bubble regions are called cells and the points are called sites. This pattern has some very interesting properties. Cell borders are equidistant from two nearest sites. And wherever three lines meet, that vertex is equidistant to the three nearest sites.
Okay, so this was about Voronoi pattern. So like we all have been teaching about Voronoi diagram. So we are familiar with these terms. So let's have a quick look at these terms once again before we get down to how to explore Voronoi using a graphic calculator. So Voronoi diagrams, one moment, I want to get rid of this. Where should I put this? I don't know. Okay, let it be somewhere this corner. So basically, what is Voronoi diagram? We all know that in mathematics, so Voronoi diagram is a partition of a plane into regions where each partition contains a spatial point, which is called seed or side. Now, this seed or side, there is a corresponding region consisting of all the points of the plane closer to that. So it is more like, you know, when we need to divide a particular region, like city planning of city. For your information, Indonesia is planning to move its capital from Java to somewhere near the Sumatra, Kalimantan side. So they will be doing a planning of city, and that time Voronoi diagrams are very, very important. So you all know like what Voronoi cells are. For example, in this diagram out here, A, B, C, and D are important points. These important points could be schools, like when you move to, let's say you move to a new city and you would like your child to go to a school. So maybe you can decide on the school on the basis of how far other schools are and considering other factors as well. So out here, assuming like A, B, C, D are for fire stations. If there is a fire somewhere or you would like to invite firefighters to honor them, then which one is the nearest? So all these things, like you all know that this is the Voronoi pattern and Voronoi diagram. So we won't spend much time here. Moving on, like in a Voronoi diagram, important locations are called sites or seeds. In some books, you'll find they use the term sites, and in some, they use the word seeds. And each site is surrounded by a region or cell that contains that point, which are all those points which are closer to that site than any other site. And the cells are labeled according to the site which they contain. For example, if there is a cell that contains site A, we call it cell A. And the lines which separate the cells are called edges. And each point on an edge is equally closest to two sides whose cells are adjacent to the sides. And then vertices are point of like points where these edges intersect. For example, when we look at this point A out here, this is called site or seed. And this green, light green region, bottle green, I don't know which shade of green is this. For me, all greens are green. But when I go out with my wife, she says there are 20 shades of green. So for me, it's light green and then dark green. So this light green is called cell. And when you look at this point, this yellow one somewhere here, This is a point where these vertices, these edges meet. We call it vertex. And this one, the red one, is called an edge, right? So these are like terminologies we use in the Voronoi diagram. Now, once the Voronoi diagram has been constructed, we can interpret it in so many different ways. There are some applications of this Voronoi diagram. So moving on to those applications, there are mainly two applications. From examination point of view, what students need to know is number one, number one is nearest neighbor interpolation problem. So what exactly is nearest neighbor interpolation problem? Out here, we estimate the data. We estimate the properties of some point or some important point on the basis of the given data. For example, like in a Voronoi diagram, when a new important point or site is introduced, we can use the nearest neighbor interpolation to estimate the data value at that new site. For example, on a snowy day, snowfall in inches was measured in 4 locations across the city. So location A, B, C, and D. So, and this is a Voronoi diagram representing that city and the snowfall. So if you see A, when we draw Voronoi diagram, and how do we do this in a calculator? We will discuss in a while. So this is point A, B, C, D. These are locations of 4 locations. In location A, snowfall is 7 inches. It means everywhere in this region, at every point in this region, snowfall can be assumed, can be estimated to be 7 inches. Similarly, for B, this is the area, this is the region. For C, and this is for D. So now the question is, estimate the snowfall at the point P. Now, where's point P? Let's bring it down. So this is your point P. So since point P, if you see this point lies in cell A, so we can use the data from cell A to estimate the snowfall at point P, and that is, which we look here, it is 7. So this will be 7 inches. Sometimes points are not given in a region. They are given somewhere on like the boundaries. For example, this point Q. So if you see point Q is on this edge, which is the boundary of cell C and cell D. So how do we find this? How do we interpolate this one? We just take the average of C and D. So C is, if you see, C is here 12.2 and D is 9.3. So just take the mean value of these two, and that will be 10.75 inches. And if your new seed or new important point or your new location lies somewhere on the vertex, let's say point R out here. So what we do, we just take average of all the cells which contain this vertex. So it will be average of B, C, and D. That is 9 inches. So this is how we interpolate, do the interpolation using this nearest neighbor interpolation way. This is very easy, very simple, but thing is, again, this needs to be informed, this needs to be reminded. So this is how we can do nearest neighbor interpolation in a Voronoi diagram. Now, another interesting and useful application of Voronoi diagram is toxic waste. Or sometimes it is also called, let me move this one. This is also called largest empty circle problem or toxic waste dump problem. So what exactly is this problem? See, if you look at mathematically, so we will look at this mathematically and practically. When we look at mathematically or geometrically, this is the largest empty circle problem, is the problem of finding the largest circle. Sorry, this is not entered. This should be centered within the convex hull whose interior does not contain any side. Now, what is the convex hull? Convex hull is basically or convex envelope or convex enclosure is basically a convex polygon that contains all possible points. And in context of Voronoi, it contains all the seats. And when you join any of two seeds, you get a straight line segment. Then that line segment should also lie within that polygon. We usually ignore it, but it's always good if students know this. So within that convex hull, we have to find the largest empty circle which does not contain any of these sides or seeds. So this can be done by largest empty circle problem. Now, yes, when 2 points join the convex hull, the line segment completely lies onto this. So what are the practical applications of this? How can we use this? For example, let's say there's a city and someone is planning to build a slaughterhouse. And in some places in India, people are vegetarian. They are against cruelty of animal. They are everywhere against cruelty of animal. But the slaughterhouse owner has to decide a location very wisely so that he doesn't hurt anybody's sentiments. So there are 5-6 important places in the town, in the city. So where should he plan to plant that slaughterhouse so that it is not closer to any of those important points? So we can use largest empty circle problem for this. In context, let's say in Indonesia, durian tree. Someone is planning to plant a durian tree in a colony, and there are some people who do not like durian tree. So they don't like the smell. So we can find the location where that tree should be planted. So all these are like practical examples and practical applications of largest empty circle problem. So this can be used to identify a location as far as possible from given locations and also to make fair and wise decisions. Now, how do we do this? How do we, in a Voronoi diagram, how do we solve problems involving this? So let's open a document and see how it happens. So toxic dump problem. So look at this Voronoi diagram. In this Voronoi diagram, we can see there are 4 hospitals, hospital A, B, C, and D. Now, these are 4 corona hospitals, special hospitals, and they need to dump the waste from the hospital somewhere so that it does not contaminate the environment, and it has to be as far as possible from these 4 hospitals. So how do we do this? So practically, if you see this point is equidistant from hospital A, B, and hospital C. If you look at this point, this is equidistant from hospital A, hospital C, and hospital D. So in this toxic waste dump problem, what do we do? There are a few steps. Number 1, we all know. So just a quick review for every one of us. So we look at the vertices of this Voronoi diagram. Now, join these vertices from these seeds or draw circles. So you can find the distance, like out here on the screen, you can find distance of this vertex from either point A or from B or from C. All these will be same. So we can go to menu, go to geometry, points and line, and we can go to line segment, join it here. So this distance, just right click on this, measurement, this is the length. So this is 2.24. And you can check, you can go back to point and line and go to segment, join these 2. And when you find that measurement, this distance is also 2.2. It should have been 2.4. I think I moved it. Okay. So when you draw this like exact Voronoi, it will be same. So this point vertex is equidistant from hospital A, B, and C. So what we can do is we can draw a circle and check. Geometry, go to shapes and go to circle. You start a circle starting from this point and going up to this one. So you see this is equidistant. And another circle can be started from other vertex. This will also be equidistant from 3 points. Now, this is my estimation because even at this point, it looks that circle is passing through these 3 points. If I move it a bit, it still looks the same, right? So these are like estimation and error. So in the classroom, when we discuss and when we explain, we can explain to the kids that this can be ignored. Okay, so now we have two circles. So which of these two is bigger? We can easily see that the one on towards D is a bigger circle. So this center, this should be the center of that toxic waste dump area. So this is a very good point where you can have your toxic dumped. And if we do it here, then it is closer to this, means this point will be closer to these two than this one. So this is how we solve this toxic dump problem. I can see there are some questions here. The bubble approach, thank you, thank you. Okay, great, thanks. Okay, so moving on. So this is basically, Greta, this is what I feel like is something which we all need to know. And there's one more thing out here quickly. I would like everyone to recall this thing also. Locus. We used to do it long back. I have not done it for a long time when I used to do IGCSE without coursework long ago, that old syllabus. We used to do this in detail. What is the locus of a point whose distance from two fixed points is such that it is equidistant from these 2 points? P is PB, or A is closer to P, or A is closer is closer to A or closer to B, or closer and equal, closer and unequal, like that. And also, what is the locus of a point whose distance from two fixed lines L1 and L2? So basically out here, we need to recall before we get into drawing this Voronoi. What is locus of a point whose distance from two fixed point is changing and from two fixed lines? So it is equidistant from both the lines, so closer to L1 or closer to L2. So once we have recalled all these, we are all set to go with Greta. So Greta, the question remains, how can we use TI-inspired CX2 to visualize and explore Voronoi diagram? Would you like to shed some light on this?
Sure.
So what I'll do is I'll stop sharing my screen, and you please, you can share your views and your screen now. Over to you. Thanks.
Great. Yes.
Sorry, one sec. Anyone has any question or any thoughts before we continue? Wonderful. Please go ahead.
Thank you so much, Jalaj. That was very insightful. I think you took us through all the basics of the Voronoi diagram and the nomenclature involved. Now, let's begin with some geometry basics, before we understand exploring the Voronoi on the TI. So some of the geometry basics, so I hope all our fantastic 25 participants here have their TI Inspire software or the emulator or the calculators with them. Okay, so I'd like to first go ahead and plot out 3 points. Okay, just 3 points. So 1, 2, 3. Okay, now you can go ahead and join these 3 points either by using line segments, but the easiest way is just go ahead and through the polygon approach. Okay, now when you have already plotted the point, you might want to just color it so that you will later know whether it is your site, and you don't get you will later know that it is your site, and you don't get confused between the various points, because the figure might tend to get a little complex. So go ahead, hit red. Okay, you can also do this together. So multi-select and then go ahead and color, right-click color, line color, and place it as red. Okay, and then just hit enter and your job is done. Okay, now, as I said, you want to go ahead and get it connected. So menu, geometry, shapes, triangle. Okay, so go ahead and join that out. All right, enter. Okay, one sec. Okay, right. Now, in order to get your basic Voronoi, okay, for Voronoi, these things must be mastered first. So you will need perpendicular bisectors of all the line segments joining each of the 3 points. Okay, you might also want to feel free and go ahead and label the points. So as you could see in Jalaj's figure, he had labeled it hospital A or, site 1 or whatever. So you can go ahead and label it. I'm just showing you one example to save time. Now, go ahead.
Sorry, Gita, quickly. If we go to menu, in menu, we can make it by default points are not labeled, but you can choose that by default points can be labeled.
Okay.
Yeah.
Thank you. All right. Next, now you go into menu, geometry. Okay. Remember, we are now constructing. So you go into construction, the perpendicular bisectors. So you just click on the respective sides to get the perpendicular bisectors, right? So as you can see now, this one is not long enough to intersect to show you exactly the intersection point. That's not a problem. Okay. And yeah, I'm just going to move this a little bit so that, the circumcenter is more towards the second quadrant. All right. Now, you will, of course, want the circumcenter. So yeah, you can go ahead and enlarge that, elongate that. Yeah. Now you need the circumcenter here. So what you can do is go ahead to menu, geometry, points and lines, and intersection point. Okay. Click. And of course, you have your intersection point there. Okay. Escape, and you have your point here, right? Click on the point. Right click on the point and say coordinates and equations, and you will get the coordinate of your circumcenter. That's in case you need the coordinate of your circumcenter. Okay. Now, let's say you want to, that coordinate of your circumcenter, let's say you want to color it with another color. Okay. Let's go in for magenta. There you go. All right. So you can now see that you have, in a way, created a Voronoi, right? With this, let's say I'm assuming this point is B and this point is C as your sides, okay? And your perpendicular bisectors would define those regions, okay? Now things can go ahead. So once you know how to do these basics, you might want to hide the triangle. So right click, hide, okay? And then you have your region out, fine. You can make it a little more complex as well by choosing 5 points and proceeding. Shall we try that, Chalaj?
Yes, sure.
So I'll go on to Control+ and I'll insert add graphs. Okay. Take 5 points. All right. So point, let's say 1, 2, 3, 4, and 5. Okay. I'm just basically repeating the first few steps. And we'll proceed to, now I want to select all of these because these become my sides, remember? So multi-select, color, line color, and I'll put it as red. Yeah, look like traffic signals blinking. Okay. Now go ahead and join these with respect to by triangles. Okay. So go to menu, geometry, shapes, okay, triangle. Just make sure that you don't cross. Oops. That's because I had to click there. Make sure you don't cross over a segment. Okay. Right. So that's your first part. Second part. So click, 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 click. There you go. Okay. Now,
Greta, there's a question. How are you doing multi-select?
Okay. So what you can do is just click on the point and then click the rest of the points with it. Okay. Like for example, I'll just show you that once again. Yeah. Once you pressed P, just hang on. Yeah, now you go ahead and press P here and just go by point number 1. So 1, 2, 3, 4, right? And right click. Oh, sorry. So once you start, just click on it and then go and click the rest. Can you see they all start blinking? That's how I do multi-select.
Do you need to press control or any other button before that?
No, I didn't.
Just select.
Yes.
Yeah.
Okay. I hope it's clear. Jalit,
Yep.
shall I go
Yep.
back? Yeah, okay.
Yeah,
I go
please.
back to my
Thanks.
figure now. No worries. Thank you for the question. Yeah. I go back to my figure. All right. Now remember, second step was the perpendicular bisectors, because you know that the perpendicular bisector will pass through the midpoint of the respective line segment. Okay. Ideally, you know, I would love you to have labeled the points and call it a site or whatever. So, but for the want of time, let's move on. So moving on to menu, geometry. Okay, now I'm going to construct. So I'm going to go to option 4. And from here, option number 3. So with respect to every triangle, make sure that you have the circumcenters. Okay, so this triangle is done. Let me go this way. This one, this side you already have, this side. Right, this triangle is now done. Now come to the next. So here. Oh, it's looking interesting. 2 and 3.
It looks
Right?
too crowded. Can we do something?
Of course, it's all about viewing the symphony in the chaos. Okay.
Yeah.
Now, once you have your intersections done, it's important to identify your circumcenter. Okay. So for that, you need your intersections. And Hassan gave me a fantastic tip. He said, you just need the intersection of 2 lines here. So I had another way to do it, but then I thought, okay, let me use that technique. Intersection points. So click line and line. Basically, if you have 2 lines, the intersection of 2 lines is enough, right? And you can see that the point is highlighted there. So, yes.
If you try, just press P in your keep.
Yeah, I'd love to do that, but I'm already in this mode. Can I just finish the intersection and then I'll press P, okay? So 1, 2, yeah. So you already have the second point there. Remember, I'm just exploring the Voronoi diagram right now. I'm not interested in any of its coordinates right away. Okay, I'm going to do that in the later segment. Okay, then go ahead and click this line. So you have this point, right? And go ahead and click. Now you notice that, you know, nobody is even touching that guy there. But the moment you click on the line, it would have surely joined. And to see that better, there you go. Okay, so you know that your points are intact. Now, what I'm going to do is, yeah, just if you can see, I'm just adjusting this because I'm trying to get everything into one screen actually.
Yeah.
Yep. So I would now like to color these points with another color. Okay, so let me just select all these points first. Okay, so that's blinking, click, that's blinking, click, that's blinking, and click. All your 4 circumcenters blinking. Amazing. Now, fill in the color. Go ahead and put magenta. And you know now that these magenta dots are your vertices. Okay. And the red elements that you initially first plotted, your 5 points, those are your sites. Okay. Now, you can see that the entire diagram has become super cluttered, but don't worry. I'd like to, you know, show an easier method of, like, from here, there are 2 ways in which you can move further. Jalis, do we have a question? I see the chat blinking.
Oh, one moment. Sorry, I think I missed it. How were you doing? Select. No, please go ahead.
Okay. Now, so there are 2 methods. Either, you know, you can go ahead and join these by segments, but that's going to be cumbersome. So I'm going to just go into menu, geometry, shapes, and I'm going to go to polygon. Okay. Now I'm going to join the polygons from the circumcenters basically. Okay.
Mm-hmm.
So 1, 2, 3, there you go. Okay. And you can see that your polygon is placed. Grab that polygon and you want to immediately fill color because you don't want to get lost there. Okay. Yes, there you go. So now you have your central polygon in. All right. Now the reason I'm slightly zooming in is because I want to identify how I would now place these sites into the remaining regions or cells. Okay. So you can very cleverly do this by, again, going into menu, geometry, and so on. But be careful that, I have purposely left these perpendicular bisectors here. This is because you can see now that we are going to now construct the region for this site. Okay. Now your immediate question would be, oh, shall I take this perpendicular bisector, this perpendicular bisector? So many a time students get confused with respect to which perpendicular bisector to take. So if you have trouble determining which part of the perpendicular bisector to include as an edge, okay, remember that all the edges surrounding a cell are perpendicular bisectors involving the corresponding site. Okay. So let's say we are doing it for this site. Okay. Yes. So what I would do is, let me just go up. I'll go to menu, geometry, shapes, and polygon. Okay. Now I would begin by clicking, let's say, along this bisector. Okay. As you can see, right? So go along the bisector, click here, click on this vertex, which is your circumcenter, click on the next vertex, which is another circumcenter, and click here. All right. And press escape. Oh, what did I do? Okay, I'll just repeat. 1, 2, 3, and yes, done. Okay. Escape. Now grab that polygon, quickly color it. Okay. And in this way, you can fill in the rest. Okay. Now, in the process of this, please go ahead and after you've completed, please go ahead and hide these regions. Okay.
Sorry, Greta. Could you please repeat this one? Geeta is asking to repeat.
Oh, sure.
Could you please? Or maybe you could do like another region to show her how to do it.
Yeah, sure. So I'm just trying to decide which region to go in with. Okay, let me go in with this region. Okay, this region. So Geeta, here's my site. Now what I'm going to do is, remember, it's important for you to know, okay, not this perpendicular bisector, not this one. You're going to go this perpendicular bisector. Okay, because that's the perpendicular bisector of this segment. All right. And you're going to go with respect to this perpendicular bisector because this is the bisector of this segment. Okay. Now go into menu. First, make sure that you have enough place that side. Go into menu, geometry, shapes, polygon. All right. Go ahead. You might want to start from here. Start. There you go. Click. 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 Go back. Click. Okay. And escape. All right.
I think color.
Yeah. Grab that polygon and quickly color it. Okay. Green. Let's say. There you go.
Wonderful.
All right. So in the same process, you can follow and continue it. So Jalaj, I had already, tried in this, and these were some of my what I had tried, and I arrived at this Voronoi.
This is beautiful.
Now, moving further. So, ladies and gentlemen, we have now covered 2 of my learning objectives. One was the basic geometry involved, and the second is exploring Voronoi on a plane, right? Now, let's look at a question on Voronoi, okay? So, let me go to Control+ and introduce a page there, a graph page. Okay, this part, let's say you want to construct a Voronoi diagram for fixed points. Okay, so when you're clicking P, okay, I often like to call this in my mind the Jalaj approach because Jalaj has kind of reiterated this point with me. So go ahead and put -10 and 9. Okay, now you're already in this mode. So if you're clicking the next point, just press the open bracket. Okay. And then go ahead and type the next point. So 10, enter, 13. Okay. Remember, you're already in this mode. It tells you here. So go ahead and press the open bracket and type in -2, enter -7. All right. Okay. So my question was construct a Voronoi diagram for these 3 points. So basically, you're just repeating the process that you already did. Okay. So menu, geometry, shapes, triangle, right? And just click. There you go. Escape. And you might want to color this. I'm not going to do it now. Now go into the next step of getting a Voronoi into process. So geometry, construction, and you want your perpendicular bisector. So click. There you go. And you can see that they'll intersect at the circumcenters. And you will want that point. So remember, menu, geometry, points and lines. Okay, didn't exactly tell me. Never mind. I will just click it with the intersection point. Okay, escape. Jalaj, you wanted me to try in some other method here?
Yeah, when you press P and just hover your cursor on this point, it tells you this is like another beautiful example of artificial intelligence. Go to P, just take point, select point, and just hover. Go to P again.
Okay.
Point.
Yes.
Now just take your cursor on top of, so it tells you, do you want to mark intersection point? Just
yes, correct.
Just click, that's all.
And if I want the coordinates, just right click there and you have your coordinates as well. All right. And there you've constructed your Voronoi. Now, let's say from here, you want to find the equation of each edge of your Voronoi. So remember, these that you placed first are your sides, right? And this is your vertex. And these are your edges. So if you want the equation of this, just right click and there you go. Okay. So right click there and right click. There you go. So far so good? Yes. So that helps you to find the equation of each edge of the Voronoi. Okay. Now, let's say you want to find the coordinates of the vertex of your Voronoi diagram. We already did that, right? This one. And let's say you want to use the Voronoi diagram to identify the site closest to, let's say, to -3. So go ahead and put in the point there. Put in the point to -3. Enter. -3. Enter. Right? So you can see that the site closest to -3 is this here, -2, -7. Okay. So this is a method probably students can also use to develop their eyes if they are interested in setting up an eye of this nature. So Jalaj, I want to ask you, what exactly are eyes looking like in classrooms today? I mean, in grade 12s, what exactly is happening in an eye classroom?
What exactly is happening in eye classroom? So, okay, like in my understanding, maths has totally changed. From 2021, May 21, maths has totally changed. It used to be just higher maths, standard level maths. Now we have 2 mathematics, and a new thing has come into mathematics teaching learning, that is Toolkit, and there's a more emphasis on methods of proofs, mathematical modeling.
Jalaj, may I just interrupt you?
Yeah.
There are 2 people with their hands raised. So I think Aparna and Sajan have their hands raised. Is there Hassan? Can we?
Yeah, they can unmute themselves and they can ask question if they have.
Yeah, actually, I was a little interested in how we can, help our students to know exactly to incorporate Voronoi diagram for the IA sessions. Because last 2 years I'm watching them. None of my students have actually come across with any IA topic. where they have used Voronoi diagram. So since it is addressed, so I think it'll help me to understand.
Sure. Rita, would you like to?
You can go ahead, Jalaj.
First thing is like there has to be some case study. There has to be a topic where they can use this Voronoi. So students have to find, they have to do some research, a topic where something new is setting up. Maybe it's a new city or some venture, new business venture, and someone is planning to relocate things. And once it is there, then students can use Voronoi diagram there. And I don't think there can be any internal assessment exploration completely based on Voronoi diagram, because this does not give the scope to reach that level, especially for higher mathematics, when it comes to like rigor and sophistication, which we will be discussing soon. So I have my reservations on if there can be any internal assessment solely based upon Voronoi diagram. But Voronoi diagram can be a part of some IA, and we can use it to develop or to see another perspective from a different angle. We can explore it. Greta, what do you think?
Certainly, I think it is based on personal engagement. So if the student can personally connect to a situation where he or she can develop an IA based on sites and basically the concepts that lie in this idea of Voronoi diagram, right? From even basic construction of the Voronoi diagram. There's also the Delaunay triangulation method. I think they can, depends whether they want to exactly illustrate it through a problem perspective, or whether they want to focus on the math, the algebra behind it, or just the geometry of looking, or a combination of all the three.
Right. And when I was teaching Voronoi last time, we did a mini project like Indrani has mentioned. Our students have done a mini IA on creating containment zones depending upon the number of COVID patients in a locality. They use Google Map. I did it with this in Indonesia. We have something called Gojek, like this online food delivery guys. So if a Gojek guy gets, or say a delivery boy gets 20 orders, so I put graph theory and Voronoi together, and we created a project, and I don't mind sharing it. Later I can drop in the link to that one. So using graph theory and Voronoi diagram, there was a beautiful project. So I think in these areas they can use, and as Indrani mentioned, for like mini IAs, yes, it can be done. For a full IA, I doubt, honestly.
Yeah, and the next question is from Sajan. Your hand is raised if you would like to unmute.
Sajan?
Okay, I think we have happened to answer his question. All
Possibly.
Right. Okay, Jalaj. So you were telling us about, how MAA and MAI have.
Yes. So, if I go back and recall, it is for the smooth continuum from MYP to DP, or say from like DP MYP, very smooth continuum. Now we have like conceptual teaching, understanding, and diploma also. We have Toolkit, where we talk of like methods of proofs, mathematical modeling, problem solving techniques, use of technology, some like heavy emphasis on use of technology. So when the students write their IAs, so first thing is it is very important that they should use their toolkit very, very effectively. And when it comes to toolkit, I'm in touch with like so many teachers. So many of them have this perception that toolkit means simply as it sounds, toolkit, so it has something to do with technology. No, there are so many things like cognitive activators, then problem solving techniques, then doing some mathematical modeling. So this is entire process. So I feel like these days IA has become more organized, more streamlined, and it has a clearer objective than what it used to be before. And if we see, there are some shuffling, some adjustment in the criteria, assessment criteria also, like in presentation and communication are given more emphasis now, personal engagement, reflection, and use of technology has not changed much. But like in presentation and communication, they have different expectations now. In reflection also, they have modified their expectations. So in my opinion, it's more organized, and objectives, learning objectives and assessment objectives are more clear. So this is my understanding. So does this clear what you are asking?
Yeah, I think.
Okay. So why don't we continue and let's explore how can we use. Okay, Aparna agrees with me. Thanks, Aparna. So let's explore how to use this beautiful TA technology to effectively model a situation. And when we do modeling of situation, this is another very popular internal assessment where students, they model. Usually they do like trajectory, some parabolic trajectory. This, what is that game?
Angry Bird.
Angry Bird.
Yes.
And
then you'll have cannonballs,
badminton, basketball. They do so many like routine IAs in IB diploma. And they have like routine work, basic IAs, and they never reach high level. So they have to have some elements of, like, they should show their understanding. They should have some elements of discussion which can show that their IA is reaching expected level. So today we will see some of those aspects. And is it okay if I share my screen now?
Yes, please go ahead.
Okay, I'll go ahead and I'll share my screen. And my internet actually out here is a bit bothering me, so I'll keep my video off. So I hope it is okay with everyone. So today we'll explore this modeling of data with the help of data capture. Now, what I'm showing you how to do. Okay, and we can extend this to like at any level. We can do modeling of like complex phenomena, complex situations, depending upon what sort of internal assessment is this. If it is for standard level, they have different expectations. Or sometimes the students, they model logos. So you can model simple logos, complex logos. You can use piecewise functions, hybrid functions for this. So there are so many possibilities. Okay, there is no limit to this. So we are not going to discuss very high level of modeling, but today we will discuss how can we use this TI technology to do the modeling. Now, once we know how to model it, then we can apply this in any situation, because we all know that the understanding criteria for understanding is you should be able to transfer your skills. So once you understand, once you know how to do, students can, the candidates, once they know how to do, they can transfer it to anywhere. So let's get started. So let's do something interesting. Let me share my screen.
I'm actually wondering, Jalaj, what have you decided to model today?
There's something very interesting, very interesting. I'll show you in a minute. Like people, this in Indonesian we call it luar biasa. Like people usually don't do this. So I was reading through. I like to read, and I don't like politics, but I like some of the politicians in India, and one of them is Shashi Tharoor. I don't know if non-Indians know him. He is a great politician, very learned person. He used to be in UN for a long time. He worked in UN. Now he is based in India, and he is in Delhi these days, like Central India, but he's from South India. He is a great person. So I'm planning to do something to do with Shashi Tharoor.
Wow.
So I hope it is okay.
Yes.
Okay, so in the modeling, when we do modeling, So there are two things in modeling. So let me open and show it. How do I do? So let me open a graph. In the graph, you can bring in a picture, or you can bring in some data, and you see how your data is behaving. So it is more about the locus, a combination of locus and the functions. So I don't need a function out here. So what I'm going to export first is import a picture. And I'll import this picture here. Open. This gentleman is
wow. This
He's
reminds me of a famous quote by him.
Please go ahead.
There is, he said, there is not a thing as a wrong place or the wrong time. We are where we are at the only time we have. Perhaps it's where we are meant to be.
That's great.
But yeah.
Wonderful.
John, any comments?
Why do you need my approval?
No, we need your perspective, not your approval.
Good one.
Okay, so if you see, like, he's one of the style icons also, and this is all solely my opinion. So I thought he has, like, different type of hair. So can we model his hair, his hairline? Can we use mathematics to do some modeling of his hairline? So
that's an interesting choice, Jalaj. I actually first thought you were going to take his jawline. Okay.
Yeah, but jawline, actually, it is quite obvious. So
yeah, that's fine. Let's go ahead.
Yeah, going off with his hairline. So what I'll do is I don't need this grid and axis. So first thing I'll do is I'll get rid of this. So go to view, hide axis. I have this grid. So I'll go back to view and grid. No grid. Okay. Now, to model this hairline, what I need to do is I need to find lots of points over this curve where I'm moving my cursor. So I need lots of points over this area, but I don't have any point. So first thing I'll do is I will need a point here. So I'll press P, directly go to P. And if you have older version of TI Inspire, you can go through menu, geometry, point and line, and you have this point and point on. But if you have Inspire, you can directly use the shortcut, press P. So I'll press P and I'll take a point. Now, if you see, by default, when I press it, then you see it is already labeled. So that time I was mentioning it. So how to do this? Go to menu, setting, and if you scroll down, automatically label points. So you have to check or uncheck to get this labeled or not labeled. So, wow, how come this grid has come here? Okay, maybe I did something. Okay, so I'll hide my axis. I'll go back here, view, and I'll go to grid, and I'll do no grid, go to point P, a point, and I'll mark a point here. Now, the moment I mark, straight away, I can go to coordinates and equations. So I get these coordinates. Now, also I can do one thing. I can highlight this. We have done so many webinars on this. So I hope everyone is comfortable with storing a point. I can store this point as X and enter. And I can go to the Y coordinate and I can store this point as Y. So now I have two variables here, X and Y. I can move it. Let me put it somewhere here. Yeah. So now this point is a dynamic point now. When I move this point, let's see what happens to these coordinates. Do you see these coordinates are also changing?
Yes.
So this is a dynamic point now. I have defined X and Y coordinates of this point as variable. Now, where are those variables? If I click here in variable, I can see X and Y. I have two variables. Now, background is black, gray. So what I'll do is I'll change the color of this, right click, line color, and I'll make it red because this is more visible here. Now this label I don't need, but it's okay, let it be here. And if you want, you can remove this label, you can hide this and A is gone. Now I would like to move this point along these lines. And when I move this along this line, this point, I'll get lots of points. So if I find locus of these points, I'll get the function. So this can be used very effectively in an IA. And Greta, can you check? There are so many, I think in chat, we have.
Oh, yes, sure. Sorry. Yes, there are quite a few messages.
Anything relevant, anything for me?
Data capture is what
yes,
Shraddha
that's what
said.
we are planning
Yes.
to do now. So
Yeah.
we will have lots of data from when this point is moving. When this point moves, we will have data. So we need to capture that data. There are so many different ways to capture data, but the basic theory behind capturing the data remains same. So out here, if you see, you have X and Y. You have this data has X value and the Y value. So you need to capture X and Y both. So if you like to capture, you need to store it somewhere. So once you capture, you will store it. And where will you store it? You have to have a table. So what we do, we open a new page in this document. So you can go to either you do Control and Doc, or just do Control I. This is the shortcut, and go to List and Spreadsheet page. Now, in List and Spreadsheet page, it is like your Excel or spreadsheet in Google Doc. So I would like to define it as list 1, first list, and the second one as list 2. Now, I would like to capture X values in list 1 and Y values in list 1 corresponding to all these points when I move this point later. So it is very simple. In this cell, formula cell, we go to menu and data capture. Now, you can automatically capture it. You can manually capture it. Now, in this case, when your motor skills are very important, how are you moving along this hairline to mark those points? If you shake, or if you're not good like me at moving along a line, then I suggest you do manual capture. Otherwise, you can do automatic also. But out here, I'll prefer manual capture. When you do it automatically, you just have to move your point. But if you do it manually, then there is one more step here. So it's always good to learn something new. So I'll go with manual capture. Now, manually, when I capture, remember in the previous page, last page 1.1, we had defined a variable. So your calculator is asking you, which variable would you like to capture here? So either you can just print X here, or go to variable. From here list, you can write X and enter. Similarly, we go to this formula cell here, same process, data capture, manual, which variable would you like to capture? Y, and enter. Now, this is, there is nothing here. If it was automatic capture, there would have been a point which is here, this coordinate, these coordinates you would have seen in this area. Now, what you do is, now this is very important. When you move this along any place or any line or any curve, there is nothing out here because everything will be done manually. So how do we do this? There is only one thing you need to know. First thing is grab this point. Once you grab, it is like you're holding it. So you hold it and press, you take this point to a place wherever you wish to take it, then leave it and press Control full stop if it is Windows, or if you are using it on a Mac, Command, and if you're using in calculator, just Control and dot decimal point. Now see, we have marked this 2.89 and 6.04. If you go to the capture page, 2.89 and 6.03, 4. Probably I double click it. So it is there. Now, hold it, grab it, and move it to another point. You can just leave it there and now press Control full stop. Do you see 3.208,
Yes.
4.969, which is this point. Now you move it again. Slowly you can move it and Control dot. This is your third point, 4.277 and 4.403. Now 4.403. Why is it? Oh, 4.403 is 4.4. Yeah. There's someone there in chat. Can you please repeat the instruction for Mac? Oh, same thing. What you do is for Mac, you hold it and move your point, place your point wherever you wish to capture this, command and dot or full stop. So command and dot.
Jalaj, can you just show, I mean, if it's for the Mac, it's command and dot, right?
Yeah. And if it is for Windows, it is control and
control
dot.
and dot. Yes.
Yeah.
So command instead of control.
Yeah.
Thanks, John, also.
And now I'm not going to look back at those points. I'll try to capture. And more the points, better your modeling is. More the points, better your curve will be. Possibly. Okay, okay. So I have done only till this point. From here, I move and I stopped here. Or let's have one more point here. I'm stopping here for a reason. I'll tell you why I stopped here.
Is it the parting?
It is. Is it what?
Is it the parting of his hair?
No. Hold on. I'll tell you. It's mathematical. So we have, how many points do we have? We have 13 points here. Okay, 13 points with different coordinates. We have collected these points. I could have gone further, but this is giving an impression that this is going to be a cubic function, isn't it? This one. And if you further go, this will not remain cubic. So we have our first impression that it is a cubic function. So this is like sort of conjecture. You are making a conjecture if you go by scientific method. So this could be our conjecture. Possibly it is a cubic function. Now we have to test our conjecture. If it is not, you have to go back, repeat the process. How it is done, we will see. So we have captured this one. Next is the analysis part. Now, how do we analyze this? Analysis is very simple once again. So you have data. You can analyze it in two different ways. Way number one is we go back to menu and do some statistical analysis. Go to the stat calculation and find the regression.
Jalaj, before you go to the regression, there was a question from Pooja. So she wanted you to just clarify whether in order to transfer image to calculator, is it compulsory to use the software? Will it be possible using only GDC?
I think you cannot do it in GDC.
Only software has that insert image option. The insert option is there in the handheld, but only the software has the insert image, the way the picture, the image that you're inserting. But after you've inserted it, and I mean, after it's inserted it, there's no need to go to the handheld because, as it is the handheld, the screen size is smaller. So you're doing, my suggestion, you're doing this kind of exercise on in your classroom. The screen is larger. It's better to do it on the computer, on the laptop.
Mm-hmm.
For a number of reasons. But the insert image is not, that option is not available on the handheld.
Yes, it is not.
Thank you.
And also, when you do this kind of experiment, these experiments are like more for learning purpose and more for like your IA collecting data. So from examination point of view, I don't think it's advisable. And when you buy a calculator, unlike other graphic calculators, when you buy a Texas TI Inspire, you get free software for lifetime. So
yes.
Okay, so moving on. Pooja, I hope this answers your question. Any other question here?
No.
Okay, so we move on. So we go to stats here, statistics, stat calculation. Now there are so many regressions. Now, as I said, our first impression is this is going to be a cubic regression. So you can just go to cubic regression and this calculator will ask you everything. X list, where's your X list? It is in L1, list 1. Where is your Y list? It is in list 2. Now, save regression equation to F1. Now, regression equation will have some algebraic equation. So that will be saved here in F1. And anything else? No, column, this is okay. So just say okay. So once you say okay, this is all done. So this is your equation, ax cubed plus bx squared, where b is this, and plus c, and your c is this one. Now, Is it really good estimation of this one, his hairline or his hairstyle? So what we do is now go to this tab and let's draw F1. F1. It was F1 and C. See, we have covered some equation like quite of like this one, but still in this part, if you see out here, it is not, we have not covered much in this case. So what we do, should we try another type of regression? What else could be there? Now, if you look at this here, it is going up, sorry, this is a decreasing function, turning point, increasing, then again decreasing after turning point, and then going up. So maybe it is part of a quartic function. So shall we try quartic function? So let's go again here. Oops, not here. We have to go back to our data, file, data, not data, statistics, calculate. Now this time, let's try a quartic regression. In quartic regression, your list is L1, and this is an L2, and regression equation will be saved to F3. Fine. So let's try and see what F3 does here. If you take F3, we don't need this one, so let's remove it. This point do we need now? We don't actually need this point also. Okay, so try F3. And in F3, this one. Wow, F3 is F3. F3 is also like, it is quite close, but I can see like it is covering more points. Now, how do we decide which one is better? How do we know which one is better? Or like this is very close. So in this case, when you make a decision and when you, when the students, by you, I mean your students, when they take a decision, how or what are the bases in the reflection part?
Shraddha says R square.
Absolutely. Thanks, Shraddha. So R squared. What is R squared? It is coefficient of determination. So out here, if you see for this thing cubic regression, R squared is something really important. And in all these regressions, they specifically mention the value of R squared. So where is my cubic one? This one. Was this one cubic? Yes. So its R square value is 0.9842. Means around 98.42% of the data is lying on that curve. Now, if you see out here, it is 98.6%. So, which is better? It seems that this quartic is better. Now, again, like, you know, we have to look at the complete analysis. If you're really doing a good analysis out here, you may consider other factors. If you model this with quartic and cubic, what are the advantages and disadvantages? Because R squared is one of the factors. We can see how many points are there. But maybe like in the given context, cubic is a better option for approximation. Quartic is not a better model for approximation, because we can see that graph is just going down later, it won't come up. Or in this case, even if your quartic has a smaller R squared value, but when it comes to the shape of the head, or in this current scenario, or maybe, you know, we can connect it to some business, they make wigs. They're making wigs, artificial hair, and they would like to model different facial structures and different hairstyles. And being a style icon, many people would like to have hair like Shashi Tharoor. Like I would like to have a hairstyle like him. So,
Jalaj,
yep.
Can I interrupt you?
Yeah, go ahead.
I want to ask you, how do you think knowledge and understanding is demonstrated as being thorough in this example? Sure.
Wonderful. Great question. Give me 5 minutes. There are a few more things out here, then I'll come back to this.
Okay.
These components of internal assessment. So there are so many, you know, different factors we have to see. Now, if I continue this capturing these points, and if I move on in this area, and if I complete this, for example, if I move my point here, and then I do control dot. You see this thing, my curve is automatically changing. It will come closer and closer to actual one. So the quartic, cubic, so all these when you add more points, when you delete some points, so this gives you a good opportunity to see outliers straight away. Like if some of the points are not meeting your expectation, not meeting the criteria to be into a specific model, you can easily identify them and you can just throw them away from here. Now, if you feel that looking into this one, looking into different models, seeing out here is like there's too many data here. So there is another way to do this. How can we do this? Just delete all these. We don't need this. We don't need this. And this point is, I like this point. So let me put it here. Okay, so moving on. So let's open a new page now. Going on to a new page, and this time I'll add data and the statistics page. Now, do you see all these dots? These dots represent this data, which was here in list L1 and list L2. So 2.893 and 6.038. So that is one of these points. So we can do so many things out here in this page also. So what do we need to do is we just have to define our X and Y axis. So in X axis, I'll put list L1, and in Y axis goes is list L2. So this is beautiful. Okay, I was thinking why other points are not fitting. I think I made some changes, and that is why it is not fitting in here. Otherwise, it fits in beautifully. So out here, if you see your data is going like this and the square root of sine and going up somewhere here. So what kind of modeling is better in this kind of data? So again, when you are into this window, go to menu and analyze. When you analyze your graph, there is again an option of regression. Now out here, show linear regression. So if you do it by linear regression, this is your value. And students can your question, Greta, how do they show thorough understanding? So what they can do is they can write down, if it is modeled using the linear, this is what they get, y is equal to this much, where the coefficient of determination is 0.744. If they do this modeling with the help of quadratic modeling, this is the equation and this is your coefficient of determination. So they can write down like y value and the r square value, and they can keep discussing this. If they do it, they analyze it with regression of, let's say this time cubic, then this is your cubic equation and this is your coefficient of determination. So it is getting better and better from linear to quadratic, so to quadratic to cubic. Then they can adjust some parameter, they can work out, they can move this line, and
So Jalaj, two things. One is John says that, but as you keep increasing the degree of the polynomial, you will keep getting a better fit. That is one pointer. And the second is by Shraddha. She says the trend does not follow that of a linear or quadratic.
Yes, so it does not. Absolutely.
Would not that be a poor reflection?
Yes, it will be. See, out here, I'm just showing what they can look for. Like if it is initially, remember we discussed, there was a close call, whether it is a cubic or it is quartic.
Yes.
Right. Out here, obviously, it is not linear. But linear is actually something very obvious. And other than linear, there might be something. Like it could be sometime when it is exponential, you can say it is a part of cubic, or it is a part of quadratic, part of quartic, part of penta, like degree 5. So that time, to make a good call, it's always good to compare all these. I'm showing it just to show that, yes, we have an option to check this. So
Yeah, she also says, you could also be, maybe referring to the turning points would help.
yes, it depends on the like context and what kind of data is being discussed here. So turning point, certainly these are very important points. Turning point, and if there are multiple curves and point of intersection and x-intercept, y-intercept, if they have some significance, definitely it needs to be discussed.
Jalaj, with regard to the guide, if you see, there are key pointers to use of mathematics. So another key pointer there says, I want to know with respect to that key pointer of relevance, what does relevant refer to in this example?
See, relevant is when we see, like, I would say concise, relevant, all these definite. Okay, when we say like concise, relevant, these are like, few things, at times they're overlapping. So out here, when we say relevant, so anything that can enhance the discussion, or something like being in the contextual, or like say the type of math, the type of function chosen, and something is like being something to do with the bowling, or maybe tennis, and somebody comes up with exponential modeling. The model may fit, the data may fit into some model, but obviously if you're playing tennis, it can't be exponential. So being in context and making good selection of relevant data, in my opinion, that gives like
I think setting the context for the type of math that you are trying to
absolutely
explore.
Yeah. So setting the context and the type of math, type of function that you use,
correct.
I think that is
and
relevant.
When would the mathematics in this case be incorrect? So when maybe so what does correct mean here?
See, for the correct, incorrect, there are different opinions. Like some of the teachers, some of the examiners, for them, correct means it has to be correct. There's nothing like partially correct or majority is correct. Either it is correct or it is not correct. But in my opinion, as an examiner, as a moderator, as a teacher, as a human, to err is to human. So some minor, some minor if.
Hi.
Sorry?
Hi. Jalaj, can I make a point? I think sometimes, I think I love the point that you made about, taking the students through the different models. What what does R square really relate to in terms of modeling? So I understand that was it was a learning process. Unless we have these discussions in class, students don't value. They will not be able to value them. And the other thing about relevant, I was thinking, maybe they have to go back and research. Well, we were kind of modeling a hairstyle, but in real life, if they were to model some phenomenon or something, they might have to go back and research and analyze and go back and say, oh, that this is the reason why this has happened. So maybe it is relevant to the context, as Greta and you were saying.
Absolutely,
yes,
absolutely. Thank you so much for this input.
Yeah, Jalaj, I think you brought a beautiful point up of the wigs, right? So I think Shraddha was also referring to that part. Yeah.
Jalaj and Greta, we have some question from VV Ravi Rajivan in the chat.
Oh, yes.
And Pooja also wants to ask something related.
Sure. Can we shift the graph corresponding to the points on the graph by bending or something, by clicking the graph? Is it only modeling? Can we analyze? Rita, would you like to?
Can we shift the graph corresponding to the points on the graph? I would need to see the graph for that, right, Jalaj?
Usually, if you're using CAS version, you can easily do. Yes, you can move it and you can change the parameters.
If you can share your screen, Jalaj?
Sure. I'm not actually showing anything, so I stopped sharing.
All right. No worries.
So it is just this one. Okay, you mean this one, if you want to move it.
No. I think he was referring to the
Okay.
initial points, is it?
Okay, so
Rajivan, if you can just unmute and clarify your question.
Yes, Rajivan, go ahead. You mean
Hassan,
like
is he
this?
on the call? That can certainly be done, right? So
Yeah, Rajivan, do you mean like this? We can see like when we move this graph, then this equation is also changing.
No,
yeah.
I think what he meant was when you plotted those points, when you changed the position, the location of the point, there was an immediate reflection in the curve. So I wonder if it is got to do with that.
Yes.
So
Yes. So once you do the data capture, like you had data capture here. So if you change the point, anything like, in one problem, all the pages are related to each other. So if you make any change anywhere, then you will see correspondingly all connected parameters are changing here.
So he says, can we drag the previous question's graph like this? Hassan, can you unmute Mr. Rajivan, please?
Rajivan can unmute himself, like I have unmuted him.
Yeah. So that we can understand what he's trying to ask specifically. Go ahead, Rajivan. You're audible now.
I'm trying to reach that point where.
So he says, can we drag the previous question's graph like this?
Okay. We are here. These graphs?
Is it these graphs you're referring to?
Yes. I'll do is I have to go to view and show my axis. Now I can move this graph with my axis. I can move the axis to fit in it. This is what you mean?
Yes,
I think like you were doing for quadratic graph, like that he was asking, but I think here you cannot do, because these graphs are dependent on the points. You have to change the point in order to change the graph.
Absolutely. So that's what I said, like in the data capture, if you make any change to those points, then you will see there is a corresponding change. So let me show it to you here. Out here, this one. Okay, so you just keep looking at these points. What I'll do is I'll change this point to maybe 3. If I make it 3, do you see if there is any change in the graph? Oops, mismatch. Oh, I think I have to change everything. But if I move this point, let me undo first what I did before. Okay, so if I change this point, then am I capturing this point? Okay, let me capture this point. So what happens is when you make any change here, you will see there is a change in all connected parameters.
So Jalaj, I have a question. Can we do that while we are trying to model? So even I had this question, like, there was one point where I said, wow, where I could see that there was dynamic change in the graph when you were capturing the point whilst you were modeling. So I was, so that is what, is it possible to, but maybe we are too much out into the presentation and
I think if we move that point, which was captured, if we move that point, then correspondingly everything should change.
Okay.
Yeah. Yes, Pooja, sorry, does this answer the question of
yes, Rajivan?
Rajivan?
Yeah. Now, Yogita also asks, can students use Desmos or GeoGebra for this task? Yes, of course, they can use
Yeah, of course.
Desmos, GeoGebra. It's all up to, Jalaj often says this. I think, Jalaj, I think you made a mention of this, right? About which technology the student has access to at that point in time and which one they want to use for the IE.
Yeah, actually, this is always advisable. Like my experience is when we write comments, IA comments, it is always good to give a feedback to the moderator about the exposure of technology to the school. Like in some parts of Asia, especially where I work, in this part, students are not exposed to technology. And if you see, like in Cyber City, in somewhere in California or somewhere, they have different exposure. Or if the students are in like UWC, Singapore, it's totally different. They are like on top of everyone. So it's always good to mention like what kind of technological exposure students have, so that when it comes to like certain criteria like personal engagement and use of mathematics or say presentation, there can be some flexibility. When the moderator mark, he or she will keep in mind that, okay, so this child has this much of exposure. In spite of that, this such a good amount of work is produced, such a good like quality of work is produced. So these things matter. So it's always good to give some feedback to the examiner about the exposure.
So how would you illustrate, proceeding further, how would you illustrate being precise here, Jalaj?
Precise, like as it sounds, like unnecessarily repetition should be avoided, and justification of same thing again and again. It's always good to justify, validate, but if you're taking similar examples, for example, somebody is doing the modeling using the quadratic, and if he some modeling and if he uses quadratic again and again, so this won't be precise. And I would like to bring in one more thing here, like number of pages in an IA. So if number of pages exceed the recommended number, which is like 20 for HL, 16 for SL, and it is just recommendation. Candidates will never be penalized for this, because in none of the criteria, in the presentation, communication, personal engagement, reflection, or use of mathematics, number of pages are not mentioned. It is just a recommendation, because the IB feels that in 20 pages, a good HL portfolio, good HL exploration can be completed. That is what they think. It's their perspective. But if a student feels that he or she requires more pages, that's okay. They can exceed it. But they have to make sure one thing, they do not unnecessarily repeat things to make this exploration longer.
Yeah, I think that's also mentioned in the guide, that the quality of mathematical writing is important, but not
absolutely, it's not the length but the writing. Yeah.
So how is sophistication considered through this IA? Could you explain this from an SL and HL perspective? The same Shashi Tharoor introductory part of the IA that you threw light on?
Sophistication, actually, it depends on the context. Context can build the sophistication. And when you like think beyond your immediate experience, if the candidates can think beyond their immediate experience, and I think that makes it sophisticated. They have to go beyond what they see.
Yes. So I think adding to the big problem here would also help. Yeah. My next question is, what mathematical arguments and calculations define the rigor here?
Rigorous. So, again, like it depends on specifically on the exploration, but mostly connections to like type of functions, your justifications, and in this case, like if you come with some piecewise ideas, you reflect and improve upon your exploration, discuss the context, and check to see if like aim is addressed. You go back and connect back to what was initial aim, and is it achieved. And like Shruta mentioned, unfamiliar mathematics, definitely. So you have to think beyond your immediate experience. Go like people to think out of the box, but how to think out of the box is just think beyond what you see. So it may make it rigorous here. And Rajivan, last time, many of the students completed IO statistics, but the grades are very low. Just some calculations done, grade increased.
Jalaj, we have
This is the thing we noticed, sir, actually.
Sorry?
This is the thing we noticed last year's IA. That is the mathematics AI, those who are done AI, HL or SL. That is statistics IA, they are getting low mark, but those who applied little bit of differentiation, differential calculus, they got the good grade because they just attended, just applied calculus only. If any changes is there in IA, in AI or AA?
Jalaj, before you answer Rajivan, there is one question from Pooja. She's asking like, what was you doing to get the R square value after you modeled that graph in data and statistics page? How you were getting R square value in that page?
How? Sorry. So could you repeat? How do we
get the R square value? She wants to know how do you get the R square value of the various of the two of the cubic and the quadratic?
Oh, Pooja, it comes automatically. Let me show it to you once again. Okay, well, let me get rid of this first. So when you do this one, out here in this calculation, R square value, if you scroll down, you will see that R square value appears here automatically.
Jalaj, in the data on graph, data and statistics page.
Okay, this is a trick actually. I'll show you how it happened. Is first when I tried, it was not coming. So let me show you second. List data and stats. Okay, so this is your L1, and how it comes means what is the logic behind this, I don't know, honestly. I'll do some research on this, but how it comes, I'll show you. So this I'm assuming this is cubic, so I'll go to menu, analyze, go to regression, and I'll do my cubic regression. When I do my cubic regression, this is here, right? And if I move it anywhere, I don't see any R square value. So what I did, once I moved it, I think I moved it in a wrong place. So I wanted to bring it to the center. So I did Control Z. And the moment I did Control Z, R squared appeared here. So, but why, I don't know.
That's what I was wondering. Thank you.
You're welcome. And if anyone, please let me know.
How we will get, no, sir?
Sorry?
In the table itself,
yeah,
we can find
in the table it comes automatically, but out here you have to move it and undo, then you will see it on the screen.
It's a bit strange.
Yeah, it's strange, but it's very interesting. I thought only I know this. Now everyone knows this.
Yeah.
Okay, I see there is wow, discovery. Yeah, it's I think it's discovery, invention. I don't know. Okay,
Yeah.
so yes, Rajivan, your question. Sorry, and this is actually very interesting, and it is very common. Believe me, not only in your school, when the students do their this thing, IAs in statistics, they get low marks, and in calculus or in some other area, they get high marks.
That is last year only happened. That is last year only happened. That is I am asking any changes, any is there in AI or AA? Because I am the 6th year. That is I am also an examiner. But last year I noticed that those who done AI, HL level or SL level, both statics only, that is chi-square test or t-test or whatever the test or anything, hypothesis, everything done. We given 15 or like that was 16. At that time in the board exam, that is IB marked as 7 or 8. This much vast difference we noticed. Those who done statistics only.
Okay.
But those who just applied calculus, that is maximum and minimum, just drawn the graph with the TI and sphere, but they got 15. We given 9 or 10, they got 15. That is any idea or related to that one, sir?
Greta, should I share what I feel, or you want to go first?
Go ahead, Jalaj.
Okay. So Rajivan, what my experience is in statistics, it is not only this year, it happens every year. And some of these topics are so common, BMI, so many students do. And then they try to find the regression between two practical things like number of hours the child sleeps versus the IB grades, and there are so many things. Students feel whenever they are using some practical applications of mathematics, they are doing really good and they should get very high marks. That is not the case. When they do this kind of internal assessment or exploration, most of the things are done by their calculators. They just take some data, they collect data, they do some basic routine calculations, they come up with some some final conclusion and some basic reflection, and they expect a student feel that it is very good exploration. But one of the basic important essential component is they need to show their understanding. Their understanding should be demonstrated. And as you mentioned, some of the students, they have done chi-squared distribution, chi-squared test. Sadly, what chi-square used to be in paper 3 before, when it used to be option 8, statistics and probability, they used to thoroughly discuss what chi-squared is. And when it comes to errors in mathematics, type 1 error, type 2 error, students used to learn the logic behind those errors, logic behind this chi-square distribution, when to use, what to use, whether it is goodness of fate or whether it is test of independence. In the formula, what expected frequencies mean, what observed frequencies mean. So everything was clear in their mind. So when they used to work, that understanding used to reflect in their work. Now that understanding is missing. What they're doing is only the calculator task. So
no, sir, which is last year we done that is every testing also they reflected also. Then in our school, that is more than 180 IA is there. That all IA 8 teachers are moderating separately. We are not saying what is our mark. Then other teacher also will moderate the. Then we will share last. Then we will sit 1 or 2 days. Then we will evaluate how we can give the IB grade. That is the way we are doing. Last year also we given 15, at least 14, 13 or 16 also coming that one in other teachers also. But we noticed last year only this happened, changes. Because they reflected in higher level maths also, that is testing hypothesis, how they reflected. They used the many technologies, GeoGebra, then that N-sphere and the graphical, other all resources they used and reflected in each stage also. But we, last year only it happened because we noticed that one, because all the, that is 8 teachers are evaluating, moderating all the year. Then only we are giving our criteria wise, we are evaluating. Then after that, we have 1 week, we are sitting for this IA evaluation. Then all teacher will explain this student is done this way. That is why I given 2 marks or 3 marks. Like that way we are reflecting. Then also it has happened like that. That is I am asking it. But with those who done in AA, AA, we are teaching both. AA, that is just statistics also they given. Then I noticed that because the AI, actually the students and the teachers are concentrating maximum in statistics method. So that is the reason they don't want statistics IA or like that. That is I am asking.
I think teacher annotations are also important. If you have,
we are annotating everywhere, every places we are annotating.
Okay.
Maybe you can consider sending inquiry upon result if you're not happy.
I
think
because
you should.
This is
you should inquire.
I am the 6th year. I am the 6th year doing. I am also an examiner. It happen like we are doing that way. That is moderating. Then after that, we are sitting with the students. Also, any correction is there. Then we are evaluating each paragraph or wherever reflection is there. That if it is mistake, we are saying that it is mistake like that way. Then actually we are commenting every word, graph also everything.
Maybe Greta, any thoughts?
No, we also discuss in the school also, we all teachers, we are 9 teachers. We discussed this way. What happened like that way?
I'm surprised at this generalization.
Maybe new systems or AI or like that way. That is I'm
not aware of because I strictly follow criteria. So
yeah, we are following criteria.
Each of the criteria
rubrics making. Rubrics making, then how we will give mark, then each note, that is each point also criteria also the teachers comment is writing. Then all 6 teachers or 8 teachers, we are writing their comment for every IA. Then we are evaluating, then only we are giving IB grade.
Sometimes like
it happened in only AI, sir, last year, not AA.
Yes,
AA sometimes it is increased.
Right. Sometimes, when we have similar understanding, so it's always good to do collaboration outside your domain.
Collaboration we are doing. So we are
maybe I understand. But maybe, you can try sharing your ideas with, like in forum. There are so many different forums.
No, this one I sent because I given 17 marks. Very good IA. All maths teachers also discussed it. But that student got only 9 marks. 9 marks means the criteria is at least a criteria 2 getting also it become more than 9. That is we noticed also. I don't know why. How?
Sir, should your IB coordinator not have brought this up and written to IB?
Yeah, there should have been.
This is a very.
That I don't. That I don't
also the fact that I feel that Mr. Rajivan, you are saying that it has happened with more than one IA. So I certainly think that you have to introspect into how many IAs are you talking about? Okay, how many are statistic? How many are AA? How many are AI? In the AI, what is the difference? What is the difference in the level of math? And if you can put forth this through the inquiry, I think you will have a clearer method, and also put it on across the forum so people can also look.
Now I sent 1 or 2 IA in the forum also just for my understanding, because I want to understand what is the changes or what happened.
And I feel like a topic doesn't make any difference. They can do it on any topic, so we cannot.
Any topic they can do, not an issue.
No, what I mean is we cannot generalize that if they're doing a stats, they'll get low, calculus is high. No, in my opinion,
no, that is actually we are encouraging that way. Any topic they can select, any method they can select. But last year we noticed that these changes.
This is
same IA is AI, then AA is getting little more mark, more grade.
Thank you.
Also, Jalaj, I think we cannot just put criteria as 2, and 1. I don't. It much depends on the context and the personal engagement and the IA per se, the aim in the IA. What is being addressed exactly?
Absolutely.
Right? You can't just say, even if I were to get 2, then I would have got a minimum of
correctly.
10.
No, then we wrote in IB also. We want to get back that feedback.
Thanks, Rajiv.
And this year at least we can improvise, no? That is why we are.
Yes.
Then there is one question from Nandini. Can they use computer programs to perform some iterative process if they explain that iterative process in the body of IA? Yes, definitely. But remember one thing, like it happens at times in IAs and even in extended essay. If it is maths IA, it should remain maths IA. The focus should not deviate. So they cannot have like too much of computer programming or too much of physics or something else that can steal the sense of it being maths IA. It has to it is maths IA, so it has to be focused on exploration of mathematics, communication of mathematics. But definitely, like if there is anything interdisciplinary, that always enhances. What do you say, Greta?
Yes, Jalaj, my observation is that students they pick up various statistical IAs or, calculus-based IAs. But many a times I feel understanding is not demonstrated. So can you illustrate how in the Shashi Tharoor introduction bit of the IA, how you think understanding is demonstrated there?
Oh, that one. See, like again, as I said before, it depends upon the context. So if they're able to analyze, if they're able to reflect, like when they are using different models, different kinds of models, certainly they'll not use linear, but when they like say quadratic, cubic, quartic, if they're able to analyze, reflect, and if parameters are changed, if there's some parameter, then they say what is the change in the model because of change in the parameter, and in that context I'm talking. And if it means it has to have a good reflection and giving feedback to themselves and improving upon on the basis of like seeing the limitations, observing the limitations. And another thing is like they should ask themselves if they do this IA again, or if they suggest their juniors to do this IA again, how differently can they do it?
Yes, a good point.
So it and the focus, like again, if it is interdisciplinary, they can, like it comes back to the same thing again and again. The important thing is they should be able to transfer their skills. If they're able to transfer their skills and there is justification of the process in their IA, means thorough understanding is there.
Yeah. Great. Thank you, Jalaj.
This is my understanding. So like,
yes.
Okay. And Nandini, thanks. Yes, that is what I tell them. Wonderful. We also do that. Also, can they use the screenshot of GDC in IA while explaining the graph of Voronoi? Definitely. Yes, definitely. They should. And, it enhances their personal engagement also when they do this. So personal engagement is like, to make it short, personal engagement is how personalized is their IAs, how customized their IAs. Any topic which they are working on, that's okay. But how much do they own that one, that IA? How much can they say, okay, this is my IA? How much are they celebrating their learning in their IA? So it adds to everything.
I think Marie made an important point there about the programming, Jalaj, and I think that is valid. And she says, I would ask the students to write the reasoning and logical process and then put the programming in the appendix. Yeah.
Yes, absolutely. Absolutely. Thanks, Marie.
Shraddha, you were saying something?
Yeah. I just, on a lighter note, I'm thinking, Shashi Tharoor is a very empowering orator, right?
Yes.
And, yeah, I'm not impressed always by his ideas, but I'm impressed by the way that he puts his points across. So maybe a student, it doesn't have to be a HL student, an SL student who might think, okay, how do I really improve my presentation? Does the volume of the hair have anything to do with like that? So I think if you really find these finer points, find a point of connection, that is where I think, there's also customization or personalization of the topic. So it can be, it can be, they just have to really be engaged to find avenues where they can show their understanding, question, reflect, and it should be a very seamless process.
Absolutely. And like, as I said before, they have to think beyond what they see.
True.
So then only critically and creatively, they have to think, analyze, do some research. Even like they take ideas from somewhere from online, but they have to customize that idea. They may get inspiration, but they're not supposed to copy things. So
thank you, Jalaj.
Thank you.
Yeah.
Thank you so much. Thanks everyone for joining.
Thanks everyone for joining.
It was very
Thank you.
Jalaj sir, can I take 1 minute?
Yeah, go ahead.
Yeah.
I'm so sorry. Now, normally students are asking that when do they go for sine and cosine trigonometric modeling, basically. My answer to them is when you see the periodicity and the repetition, because when they see the curve of cubic, now they are confused between cosine curve and the cubic or sine with cubic. So is periodicity the only context, or do we have some other argument as well?
Yeah, this is one of the things like they have to identify the context. If something is not repeating, there is no periodic nature, like here, Shashi Tharoor's here, it's not advisable to use. We can do it with the sine also. I tried with sine curve also when I was preparing for this, but I think we have to see the context also. And again, it goes into the reflection part. What do you think, Rita?
And there's always the R-square value to also guide you through.
Yeah. But the context is really important.
Yeah.
It is same as like a number of people attending the workshop is 31.2. We are not supposed to give 31.2 as the answer. Mathematically, it may say 31.2, but practically, so context is important.
Okay.
Yeah, so you're right by saying that you have to see if it is periodic in nature.
Thank you very much. You were really generous. Thank you.
Yeah.
Thank you. Any other question? No? Thank you. Thank you all for joining today. See you next week with a new topic.
Thank you so much.
Thank you.
Everyone.
Bye.
Hi, everyone. Thank you for joining.
Thank you. Have a good one.
Thank you, everyone. Thank you. Thank you very much.
Thank you, sir. Thank you.
Hassan, are we staying here or shall we move on?
Yeah, we can go. No problem.
Yeah.
Yeah.
Where is the Revti? I didn't see Revti today.
Repti joined, but she left.
Okay.